Okay, next we have the properties of Coulomb force. Now let us discuss about that. The Coulomb force is two body interaction. That means if you consider two point charges here, Q1 and Q2, the Coulomb force between these two point charges doesn't depend on the presence of third charge. Whether the third charge present here or not, even if it is present, the force between these two charges, whatever the magnitude is there, that doesn't change. That's why it is called two body interaction. ಅಂದರೆ ಯಾವುದಾದ್ರೂ ಮೂರನೇ ಚಾರ್ಜ್ ಈ ಎರಡು ಚಾರ್ಜಸ್ ನಿಯರ್ಗೆ ತಗೊಂಬಂದಾಗ ಈ ಎರಡು ಚಾರ್ಜಸ್ ಮಧ್ಯೆ ಇರುವಂಥ ಫೋರ್ಸ್ ಏನಿದೆ ಅದರ ಮ್ಯಾಗ್ನಿಟ್ಯೂಡ್ ವೇರಿ ಆಗಲ್ಲ. ದಟ್ ಈಸ್ ಎಫ್ ಈಸ್ ಈಕ್ವಲ್ ಟು 1/4πε0 ಇಂಟು ಕೆ Q1 Q2/r² ಏನಿದೆ, ದಟ್ ಮ್ಯಾಗ್ನಿಟ್ಯೂಡ್ ರಿಮೈನ್ಸ್ ಕಾನ್ಸ್ಟೆಂಟ್. ಇದ್ರದ್ದು ಫೋರ್ಸ್ ಏನಾದರೂ ಕ್ಯಾಲ್ಕುಲೇಟ್ ಮಾಡಬೇಕು ಅಂದರೆ ಸಪ್ರೇಟ್ ಆಗಿ ತಗೋಬೇಕಾಗುತ್ತೆ. ದೆನ್ ಆ್ಯಡ್ ಇಟ್. ಲಾಸ್ಟಲ್ಲಿ ಟೋಟಲ್ ಫೋರ್ಸನ್ನು ಫೋರ್ಸ್ ಟು ದಿಸ್ ಒನ್, ಫೋರ್ಸ್ ಟು ದಿಸ್ ಒನ್ ಅಂತ ಆ್ಯಡ್ ಮಾಡಬೇಕಾಗುತ್ತೆ. ಕ್ಲಿಯರ್? ನೆಕ್ಸ್ಟ್, ಸೆಂಟ್ರಲ್ ಫೋರ್ಸ್. ಸೊ Coulomb force is central force because the force acts along the line joining the two charges. ನೋಡಿ ಇಲ್ಲಿ ಯಾವುದಾದ್ರೂ ಒಂದು ಎರಡು ಚಾರ್ಜಸ್ ಮಧ್ಯೆ ನೀವು ಎಲೆಕ್ಟ್ರೋಸ್ಟಾಟಿಕ್ ಫೋರ್ಸ್ ಅನ್ನು ತಗೊಂಡಾದ್ರೆ ಇಲ್ಲಿ ಸಿ ದೇ ಆರ್ ಗೆಟಿಂಗ್ ಅಟ್ರಾಕ್ಟೆಡ್. ಹೇಗೆ? ಅಲಾಂಗ್ ದಿ ಲೈನ್ ಜಾಯಿನಿಂಗ್ ದ ಟೂ ಚಾರ್ಜಸ್. ಅದೇ ಪ್ಲಸ್ ಪ್ಲಸ್ ತಗೊಳ್ಳಿ, ಇಟ್ ರಿಪೆಲ್ಸ್ ಅಲಾಂಗ್ ದಿ ಲೈನ್ ಜಾಯಿನಿಂಗ್ ದ ಟೂ ಚಾರ್ಜಸ್. ಯಾವ ಲೈನಿನಲ್ಲಿ ಅಲೈನ್ ಆಗಿದೆಯೋ ಅದೇ ಲೈನಲ್ಲಿ ರಿಪಲ್ಸಿವ್ ಫೋರ್ಸ್ ಇದೆ. ಮೈನಸ್ ಮೈನಸ್ ತಗೊಳ್ಳಿ, ಸೇಮ್ ಅಲಾಂಗ್ ದಿ ಸೇಮ್ ಆಕ್ಸಿಸ್ there is a force of repulsion. So if the force acts along the line joining the two charges, so that is called central force. Then it is a stronger than this force is stronger than the gravitational force. What is gravitational force? F is equal to g m1 into r². You can take the force between one electron and proton. Gravitational force calculate ಮಾಡಿ ಎಷ್ಟು ಬರುತ್ತೆ, and electrostatic force calculate ಮಾಡಿ ಎಷ್ಟು ಬರುತ್ತೆ. So electrostatic force will be much greater than gravitational force. Okay, so that is one thing. Next, it obeys inverse square law because the electrostatic force is inversely proportional to r². As the distance increases, force between the charges decreases. So 1/4πε0 into k Q1 Q2/r² is the formula for Coulomb force. So it is inversely proportional to r², just like gravitational force. Gravitational force also obeys inverse square law, g m1 into by r², right? Like that. Then we have, it is medium dependent. Gravitational force doesn't depend on the medium, but electrostatic force depends on the medium. So F is inversely proportional to dielectric constant. Correct? No? Then it obeys Newton's third law. ಅಂದ್ರೆ ಏನು? Let's consider ಇಲ್ಲೊಂದು ಬಿಗ್ಗರ್ ಚಾರ್ಜ್ ಇದೆ, ಇಲ್ಲೊಂದು ಸ್ಮಾಲರ್ ಚಾರ್ಜ್ ಇದೆ. ಎಷ್ಟು? ಇಲ್ಲಿ 1 ಕೂಲಂಬ್, ಇಲ್ಲಿ 20 ಕೂಲಂಬ್. Okay, let's consider two charges. One is with more magnitude, one is with less magnitude. Which one experiences more Coulomb force? Both experience equal force because force is directly proportional to Q1 into Q2. So 20 into 1 or 1 into 20, both are same, right? So Q1 into Q2 we are taking. So force acting on this due to this one is equal to force acting on this due to this one. That means F21 in this direction is equal to F12 in this direction, but the direction is different. For every, what does the Newton's third law states? For every action there is equal and opposite reaction. Similarly here, the force acting on the first charge due to second charge is equal to minus force acting on second charge due to first charge. Alva? Correct alva? So ಇಲ್ಲಿ same magnitude ಇರುತ್ತೆ, opposite direction, because we take the force which is the product of two charges. Then we have, it is applicable for point charges, mainly the Newton's Coulomb force is applicable for point charges, not big spheres and all. Then it can be of both attractive and repulsive. Coulomb force can be attractive when the charges are opposite in polarity. Coulomb forces are repulsive when they are in the same polarity. Plus plus repel each other, minus minus repel each other, plus minus attract each other. So these are the properties of Coulomb force. Now we'll discuss about how to write the Coulomb force in vector form. Okay.